Hello everyone, today we will start 8.5 of sequence series Algebra 2. So using recursive rules with the sequence. There are two types of forms. One is explicit rule and recursive rule. Explicit rule is used to find any term by just substituting n. Recursive rule is a rule that will be defined in a way so you can calculate the next term only if the previous term is defined. If the previous term is defined, then you can calculate the next term only. So that means an is depend upon what is an minus 1 and some digit. But explicit form is an equals to a term just n. It's a depend upon n. There is some multiples or something. So explicit rule depend upon n. Recursive rule it's depend upon what is the previous term. Let's start with the A part. Write the first 6 term of the each sequence. A naught is 1. An is an minus 1 plus 4. So see, this is recursive rule in which it says an will be defined only if the previous term add with 4. A naught is already given 1. If I have to find A1 is equals to A naught plus 4. So 1 plus 4 is 5. A2 will be 5 plus 4, 9. A3 is 9 plus 4, it's 13. A4 will be 13 plus 4, 17. A5 is 17 plus 4, 21. And A6 is 21 plus 4, 25. So we got like this. So we find the 6 terms. Okay, done. B part, if we try, f of 1 is already provided. So we have to start with f2. f2 equals to 3 times f of 2 minus 1. f 3 times 1. It is 3. F of 3 is equals to 3 times f of 3 minus 1, 2. And f of 2 is 3. So it is 9. You can calculate the next terms accordingly. Okay. Then it's a recursive rule. Recursive rule for arithmetic sequence and for geometric sequence. For arithmetic, an will be equals to an minus 1 plus common difference b. For geometric, an is equals to an minus 1 times r. Alright. So we have to solve for a part. Let's see what type of sequence it is. 3 changed to 13. It's not a multiple. It's just adding 10. 10. 10 and 10. So every time we are adding 10 here. Okay. So it is a arithmetic. So an is equals to an minus 1 plus difference, that is b. While writing this, you have to mention the first term. First term is 3. This is recursive rule. Next, this second one. 16 changed to 40. Then 40 changed to 100, to 50 and so on. Let's see. It's not addition because here the difference is small, but here difference is very large. It's not a difference. It's not a arithmetic sequence. Let's check for geometric. 40 over 16. 8 2s are 16, 8 5s are. So 5 by 8. 100 over 40. 20 5s are 20 2s are. So 5 by 2, 5 by 2 is the ratio. An is equals to An minus 1 times the ratio. And the first term is 16. Is the answer. Here is the recursive rule. Next, we have to write a recursive rule for these C. You can see the first term and the second term is same. It's not addition. But the second term, then the value is getting increased. So in that case, if the sequence is not arithmetic, not geometric, try to find some other pattern in this. 1 and 1 is 2. You can see that this number is an addition of last two terms. 3 is the addition of these two terms. 5 is addition of these two terms. So previous two terms are used to find the term. We can write An is equals to An minus 1 plus An minus 2. With the given term, first term is 1 and the second term is also 1. This is a recursive rule. You can try this also. How this term is formed. 1 into 1, then 2, then 6, then 24. How it is forming. How it's formed. The multiple. A0 is given as a 1. A next term will be n times previous terms. You see, 1 can be 1. This is 1 times 2 minus 1. This is 2 times 3 minus 2. And so on. You have to do like that. So An is equals to n times An minus 1. With the given term, A0 is 1. Done. We are done with this. Okay. Let's see. It says write a recursive rule for An. And An is equals to this. Bn is this. So it is an addition. So it means what is that? It is a arithmetic sequence. What is the first term? A1 minus 6 plus 8 is 2. So An is equals to An minus 1 plus the common difference is 8. With the first term is 2. Done. This is recursive rule. Next, in this case, the first term is minus 3 half to the power 0 minus 3. An is equals to An minus 1 times R. R is 1 by 2. The first term is minus 3. Done. So here we have to write explicit form. Recursive form is already. In the explicit form, what is the explicit form of arithmetic sequence? First term plus n minus 1 b. First term is negative 5, n minus 1 as it is, and the difference is minus 2. Because if you compare with the arithmetic sequence recursive formula, this is plus d. So our d is negative 2. You can open it. Minus 5 minus 2n plus 2. Minus 3 minus 2n. We are done with this. This is the explicit form here for the question number 8. Next is A1 is provided as a 10. An is 2 times n minus 1. So it is a geometric sequence. The geometric sequence has the explicit form A1 r to the power n minus 1. First term is 10. Common ratio is 2 to the power n minus 1. The explicit form. Okay. So we have done up to this. Let's do the next one. A lake initially contains 5,200 fish. Each year the population declined by 30% due to fishing and other causes. So the lake is restocked with 400 fish. Write a recursive rule for the number n of the fish at the start of the nth year. So as we are saying nth term, 30% is getting declined. Okay. So 1 minus 30%. So 70%. So 70% are still there of original. From the total 5,200, 70% are still there after every year. We can write En is equals to 0.7. I'm again telling you how I get 0.7. 30% is decline. So 70% still there. Still there. So present ratio is 70% of whatever was the starting. So ratio is 0.7. And nth year, an minus. And after that they add 400 fish more. This is the formula. So you got a recursive formula. A1 is 5,200 with an is equals to 0.7 a of n minus 1 plus 400. This is the formula. B part. Find the number of fish at the start of 5th year. So we have to find how many fish are there in the 5th year. So let's find out. An to be 5. So A1 is given, calculate A2, calculate A3, and then calculate A4. Once you calculate A4, substitute here. An, it's a 5 now. A5 is equals to 0.7 times this A4 plus 400. This is the homework for you. You have to calculate yourself. Substitute the values here and calculate. Okay. Next, describe what happened to the population of fish over the time. So if we check that the population over the time is, we have to draw the graph for this. If we draw, we will get a graph that looks like this. It's at a 5,200, then it's getting decline, and all values are about 1,333. So you will get that all the fishes for over a large time, the fish is getting stable. The population of 1,333. It's getting stabilized after some years. Okay, the next question is, it says you borrow this money at 6% annual compound in monthly compounded monthly for 30 years. The monthly payment is this one, 899.33. Find the balance after third payment. What will be the payment in the third time? Or what is the balance left after paying third payment? Okay, let's find its equation. Rate is 0.06, but it is annually, but it is asking monthly, so divide by 12. If I divide by 12, I will get 0.005, and the first payment was 899.33. So we are writing an equation in the form of C, recursive form. An is equals to this number. Because it is getting increased, interest is applied, so it is a 1 plus r. So your rate is this. So 1 plus r become 1.005. Then what was the previous payment? Minus what you have paid, 899.33. So we got a recursive rule for this. We have to substitute the values one by one, and then we can calculate. So after first payment, the balance will be 149850.67. After second payment, 149700.59. After third payment, 149549.76. So this is what we got after third payment. So after third payment, this is our balance. Question is asking for this. Then it says find the amount for the last payment. You have to continue go like this. You have to use calculator in this case. So once you're done, you will get there are some values, negative values, and it is not possible you have to do a negative value. So we can check that what is the value you will get, so the balance is negative. Balance will be negative, will be added 361 payment. So you have to show that the last payment will be 899.33 was a monthly payment, and the last you are getting negative 3.91. The first negative term. And negative we can't pay, so just subtract 3.91. On subtracting, we are getting 895.42. This is the last payment we made. Why this so? Every month we are paying the same. But when we are paying like this, the last payment is not that much. It is a small less than the whatever we already paid. So we can't be negative. The payment cannot be negative. So we have to subtract this negative part. So we are getting 895.42 as a last payment. Okay, this is the last payment, and this is the balance after three payments. Balance after three payments. Okay, so we are done with chapter 8. I hope you understand. Thanks for watching.